Okay, chapter 3 is systems of equations and inequalities, which I hope is going to bring back some memories from Algebra 1, because it's a big idea in Algebra 1 that we're going to solve two equations at the same time. So when you solve a system of equations, it's two or more equations with the same variables, and we want to find where it's true for both, which says to solve, you want to find the ordered pair that satisfies all equations. So like if I graph one equation, and then I graph the other equation, the only point that works in both of them is where they intersect, right? So today we're going to solve by graphing, and maybe you have some memories of how to solve it algebraically. That's going to be the next day. But how do we solve by graphing? Well, step one, you got to solve it to graph, right? So to me, if we're graphing linear functions, we're just going to put them in slope-intercept form. We're going to graph them, and then we're going to check to see where they intersect. So step one, I got to put this in slope-intercept form, which means I'm going to subtract this 2x over. So that would become negative 2x plus 5. And just subtracting that over, right? And on this one, kind of be careful. We could either subtract the x and divide by 1, or what I think is easier is if we add the y over and then subtract the 1 over. So think about what that would give me. I would give me y equals on this side, and over here I would be left with x minus 1. So now I'm going to graph them, and I hope after the last test we feel okay graphing linear equations. This is my y-intercept, so I'm going to go up here to 5, and my slope is negative 2, so I'm going to go down 2 over 1, down 2 over 1. And this is where you want to kind of maybe make a lot of points, because you're trying to find that point where they intersect. And then if I graph x minus 1, that would be a y-intercept of negative 1 and a slope of up 1 over 1. And that's going to look like this. And the only point where they intersect is right here, right? So your answer is that ordered pair, the x, which would be 2, and the y, which would be 1. So that is the solution to that system. And so I said check your answer. I don't really need to see that you're checking your answer, but just know that should work in both of them. So if I plugged 2 in for x here, that would be 2 times 2 or 4, plus 1 equals 5. And if I plug it in here, 2 minus 1 equals 1. It should work in both of them, so if you're ever unsure if your answer is correct or not, that's how you can check. Okay? So, what can happen when you graph two lines? Well, normally what we get is like what we just saw, right? We get two lines that intersect, which means how many ways can two lines intersect? You get exactly one solution, right? What about parallel lines? If I have two lines that are parallel, how many times are those going to intersect? Those are never going to intersect, right? So that's going to be no solution, because sometimes two lines don't ever intersect. Or what can happen if I graph a line and then I graph another line right on top of it? How many times do those intersect? Well, we say infinitely many solutions. Infinitely many solutions. Because they intersect at every point, all right? And that's what you talk about in Algebra 1. We're going to go a step further and name them with some different words. So here are some vocabulary words. Consistent means at least one solution. So that means it could have one solution or it could have more than one solution. And inconsistent means no solution. So let's go back here and think about naming this. Intersecting lines, does it have at least one solution? Yes. So intersecting lines would be consistent. Parallel lines have no solution. So is that consistent or inconsistent? This would be consistent. Inconsistent, sorry. Inconsistent. And infinitely many solutions, does that have at least one solution? Yes. So this would be consistent. And then the other word we can use to describe a system is independent or dependent. Independent means if it has exactly one solution. Dependent is if it has an infinite number of solutions. So, one solution, sorry, I went the wrong way here. One solution is going to be consistent and independent. I like to say because it's only one solution, it's independent, right? It doesn't need anyone else. And this one has multiple solutions, so it's dependent on the other ones, right? So it's consistent and dependent. So that's some new vocabulary that I'm going to keep using to try to help you to learn that, okay? So let's solve these by graphing and then classify as consistent and independent, consistent and dependent, or inconsistent. And again, step one to graph these is we want to put these in slope-intercept form. So if I put this in slope-intercept form, again, you have some options. I like the option of adding the y over and then subtracting the 5 over here. So I get y equals x minus 5 instead of dividing by a negative. And then on this one, what would I do first? Well, I hope you said subtract x. And again, you can write negative 4 minus x, but I really like mx plus b, so I just turned it around because I'm allowed to do that as long as I keep my signs. So I write it as negative x minus 4. To solve it for y, I need to divide by 2. And that's okay because this is just our slope, right? So that's negative 1/2 x minus 2. Those are my two equations. Now I have to graph it. So x minus 5 means I'm going to go down here to negative 5, and my slope is going to be up 1 over 1. And notice I make a lot of points because sometimes it's hard to connect those correctly, and I want to make sure that it's crossing at a nice point. And negative 1/2 x minus 2, that would be a y-intercept of negative 2. And a slope of negative 1/2, so down 1 over 2. Really nice when I already see where they're crossing, right? My answer is where they cross, so make sure that you give an answer, right? My answer is that ordered pair, which is x first, so that would be over 2 down negative 3. And if you really want to check, plug that in and make sure it works. Since it crosses in one point, we would say this is consistent and independent. Let's do another one. Step one, put this in slope-intercept form. So on this one, I'm going to subtract the 3x over. So that would be negative 3x plus 12. And then what would I do? I would divide everything by 4. So that would give me negative 3/4 x plus 3. And again, it's okay that this is a fraction. So if I graph that, that would be a y-intercept of 3. Then down 3 over 4. Down 3 over 4. And then what if I do the other one? Well, I'm going to subtract my x first, so that's negative 6x minus 16. Then I'm going to divide by 8. And you can leave your slope as negative 6 over 8, but I think you should reduce it. You can divide both of those by 2, so you get negative 3/4 x minus 2. Right away, I see what's happening here, right? This one has a y-intercept of negative 2, but it also has a slope of down 3 over 4. Or up 3 and back 4. And look what happens to these lines. These are parallel lines, right? Which means what's my answer here? My answer is there is no solution. There is no point where they intersect. So how do I classify that? I say that is inconsistent. All right, so that's the solution. That's the classification. Okay, so this is my last one, so I will start here in class, but I want you to first put these in slope-intercept form and tell me what you think the answer is, and we'll start there in class tomorrow.